9 months. But especially with wireless and flat rate data plans, that means there's this widening gap between the traffic growth and the revenue associated with the traffic growth, and that's a big problem for operators, both in terms of the profit, cost, revenue type model, as well as just physically keeping up with the infrastructure and quality of service and differentiating one operator's service from the next. The projected supply or ability to deliver video or any type of packet-based information is expected to not nearly be able to keep up with the projected demand. And so this is both a challenge for operators and equipment providers as well as an opportunity to differentiate. And the way I think about video, it's the killer app. Everyone talks about, well, what's the killer app? Well, this is the killer app, but maybe not in the sense that people usually refer to killer app. This is the network killer app, and doing nothing is really not an option for wireless operators. They have to do something. They have to manage their network traffic. Otherwise, they will be crushed, quality of service will suffer, and end users will churn. So before I go on, I'm going to interject a poll question here, so I invite you all to respond. Basically what we're asking is, which are the most important areas of consideration in order to have a high-quality mobile video experience? Brian asked a similar question in his poll, but this is slightly different in that one can choose all of the above. And so when you're answering this, I want you to think about, iPhone, 3G networks, HSPA, local edge caching, and the potential impact of internet offloading, basically diverting traffic before it goes through the mobile core. So we're starting to get some results in. Just give it another moment. Okay, so here are the results as they stand now, and I'm actually happy to see the vast majority have answered all of the above. And this is really where I was kind of leading with my whole session here. There's no one kind of linchpin or one kind of saving grace for the overall end-to-end user experience. Capacity certainly helps. The end user devices, smart devices, and their capabilities to process the information. I'm actually surprised there's no data points really there for the actual storage and traffic flow, because I'm going to talk about the ability to affect the end user experience with things in the network that affect traffic flow. So 4G or fatter pipes is not a panacea. It's certainly a large increase in capacity from 3G or HSPA or HSPA+. There's about a 4x increase in spectral efficiency, but wireless bandwidth, unlike wireline bandwidth or networks, is a shared and very finite resource, whereas in the wireline world, operators can throw more fiber at the problem, which for all intents and purposes has a near limitless capacity. Clearly there are limits, but for all intents and purposes with wavelength division and multiplexing and just the massive amounts of capacity that can be put on wavelengths, wireline bandwidth is not an issue. Wireless bandwidth is definitely an issue, and so just adding a fatter pipe is not nearly enough, because as we saw, the demand for video in particular, or any bandwidth, far exceeds the abilities to supply. So operators need to manage their traffic. They need to shape it. And I'm going to start talking about DPI now, and DPI has got somewhat of a bad rap in the press in the last 6 to 9 months. But DPI is it's a technology. It's deep packet inspection. It's how operators employ the technology which will determine whether people perceive it as a positive thing with benefits or a negative thing with ominous undertones. The reason why wireless operators in particular need to manage their networks is because if they don't, then a minority of users, particularly the peer-to-peer type users, will consume or gobble up most of the bandwidth available. And again, this is a shared resource, which means the majority of subscribers end up having an unsatisfactory user experience. So kind of just leaving it open, best effort or first come, first serve, or catch as catch can, that is not a practical approach to wireless networks and wireless service delivery. And with due respect to the FCC and some of the policies being discussed right now, it's our position that wireline policies do not work for wireless networks because of this very reason of the limited spectrum and what operators need to do to manage service delivery. So let's talk about DPI, deep packet inspection. We think of it as being able to deliver smart pipes, smart as opposed to dumb pipes. So wireless operators that do not manage their traffic have what I'll colloquially call a dumb pipe, meaning little insight into the traffic flowing through the pipes, ability to prioritize, block traffic that is maybe spam or known bad sources, and then manage the traffic, either the traffic types, i.e. applications, or for specific users or suppliers of content, the ability to have tiered service levels. And so this is on both ends of the pipe, both at the subscriber level, the consumer level, the opportunity to, for example, pay more for a higher allocation of bandwidth. This could be for specific video packages, gaming packages, things that are high density, high volume type of content, as well as on the other end of the pipe, the supply end. So if a certain content provider wants to provide, higher quality of service than another content provider, then the opportunity to, using market-based pricing to pay more to have a higher allocation of bandwidth. Again, these are policy issues. Operators can, determine them in conjunction with subscriber-based feedback and market-level forces, but DPI enables operators to do this, and in so doing, monetize their networks, not simply watch as content providers gobble up the value in the whole service delivery chain, because more and more we're seeing the subscribers identify the quality of their experience with the content provider, not necessarily the network provider. And this is exactly what operators do not want to see, is kind of this end run by the content providers, the over-the-top providers, gobbling up the bandwidth. So by employing DPI, it enables the operators to monetize their pipes. So how is DPI deployed? And, does DPI as it exists in the wireline network, because DPI has been used there for some time, is it a one-to-one comparison for the wireless network? Well, yes and no. As you might expect, the current deployments of DPI in wireless networks, basically at the beginning, they crudely mimic the wireline DPI deployments. And in the wireline world, it's what we call a bump in the wire. It's basically a box, a DPI box that is in between two elements, and it quickly processes packets as they come through and can prioritize according to policies that the operators have set, and go on its merry way. If it fails, it's what's called fail to wire. It's as if the box were not even there, and it does not disrupt any traffic flow. And this is how wireline operators can provide these differentiated levels of service, throttling of content which is deemed to be of lower priority from whatever mechanism, as well as legal intercept, law enforcement type things, the phone tapping, if you will. Whereas in wireless networks, whether it's LTE or WiMAX, the access technology itself is almost irrelevant in this regard. From an architecture standpoint, how DPI is deployed in a wireless network is different. The way it is in the wireline network is not the best fit for the wireless network. And the primary reason for that is a different operating environment in the sense that there is a location element and an adaptive loading element. So, for example, a site which is not busy for much of the day may get very busy at certain congestion or